Okay, now we're going to look at two examples of. So the first example is a linear equation. F of x equals negative 2x plus 7, and I want to find the average rate of change between x equals 0 and x equals 4. Okay, so the first thing I'm going to do is I'm going to plot the points. So when x equals 0, f of 0 is 7. So I'm going to plot the point 0, 7. And then when x is 4, f of 4 would be negative 1. So I get the point 4, negative 1. And I'm going to draw the function. Okay, and the average rate of change is just the slope of this line, and the slope of this line can be found right here. So the average rate of change of a linear function is just the slope. It's right there in the equation. So the average rate of change is negative 2. Okay. Now I want to look at an equation that's not linear. This is a parabola. F of x equals the quantity x minus 3 squared. So first I want to find the average rate of change between 1 and 3. Okay, so when x is 1, if I fill 1 into f of x, f of 1 is going to be 4. So 1, 4 is right around here. Okay, and then when x is 3, f of 3 is 0. So I have this point right here. The secant line connecting those two looks like this. So when we find the slope between these 2 points, it should be a negative slope because, as you can see, the secant line has a negative slope. Okay, so the slope is just the difference in the y values divided by the difference in the x values. So 4 divided by negative 2. So my average rate of change would be negative 2. If I wanted to find the average rate of change between x equals 4 and x equals 7, then I want 4, and f of 4 is 1. 7, and f of 7 would be 16. So if I look at those 2 points, 4, 1's right about here, and then 7, 16 is up here. So the secant line would look like this. So when we find the average rate of change, we should have a positive number because this line has a positive slope. So 16 minus 1 divided by 7 minus 4, so 15 over 3, so 5 would be my average rate of change.